Welcome to the Rock tutorial class. This is physics class, so I'll be taking through questions and their solution to some of these Jamb questions. So I'll start from number 1. A transformer is connected to a 240 voltage supply. The primary coil has 40 newtons and the secondary is found to be 960 volts. What is the ratio of number of turns of the primary coil is the number of turns of the secondary coil? So I will take the question from this formula to it now. Having the potential difference in the secondary over that in the primary will give the number of turns in the secondary to the number of turns in the primary. And as the question specifies, we have a transformer is connected to a 240 voltage, which will now give us that of the primary. So 960 for the secondary, then 240 for the primary, equals to number of turns now in the secondary over number of turns in the primary. So with that 960 over 240, then the question says, what is the ratio of the number of turns of the primary to the number of turns of the secondary? So what I have to do is to cross multiply what I have as nx over np. So I'll have 960 np equals to 240 nx. And the question says I should get the value of my np against the nx. That will amount to the ratio of the number of turns of the primary to that of the secondary. So I'll have 240 ratio 960. So with this, I will divide to the lowest multiple using 240, 240, and 240 will go in 240 one time. Then 240 will go in 960 4 times. So the answer to that question will give us option A, which is 1:4. So shall we go to the next question? We go to question number 2. And the question is, a magnet is moved through a coil of wire. The electromotive force produced in the wire depends on. So we have the factors. The number of turns in the coil. That magnetic field, the electromotive force actually depends on the number of turns. Then we have also the strength of the magnet. And likewise the speed at which the magnet is moved. In that case, option A, B, C, we have all of the above. The EMF produced in the wire depends on all of the above. That is the number of turns in the coil, the strength of the magnet, and likewise the speed at which the magnet is moved. For question number 3, the density of a certain oil on frying becomes 0.4 gram per meter cube with a volume of 20 centimeter cube. What will be its initial volume when its initial density is 0.8, assuming no loss of oil due to spillage? So what we have to do here, we apply the formula of density equals to mass over volume. So in the question, we don't need mass because mass was not given in the question or was not even mentioned. We make mass object of the formula. So in that case, we have density multiplied by volume. So as we have D1, V1, initial density, initial volume. So we have density, final density, and the final volume indeed. So in the question, we're given the density of a certain oil on frying becomes 0 with a volume of this. So why don't we have a 0.4, then multiply by 20 as our final indeed. Then in the initial, we have a 0.8 multiplied by the volume. So I want to make V2 solve the formula. So V2 now give me 0.4 multiplied by 20 over 0.2. So for me, if 0.4 can go in 0.8, that will be 2 times. And 2 will go in 20, that is 10 times in centimeter watt cube. So the answer to that question will now be in, that is A now. So A, next question. So if a container is filled with ice to the brim, what volume or what will happen to the level of water when the ice completely melts? So what we actually have to observe here, the ice itself occupies a particular volume within the water vessel. So when it melts, the water level will still remain unchanged, because as it melts, the same volume it actually occupies will still remain the same. In that case, so the option says the water in the glass will overflow. No. The level of water drops. No. The level of water remains unchanged. So that gives us the answer to that question. So we'll go to the next question. So the next question is spring 20 centimeter long is stretched to 25 centimeter by a load of 50. This has to do with Hooke's law. And from the formula, we have force proportional to the extension. So if I want to remove the sign of proportionality here, I will introduce a constant, which is elastic air constant. But mind you, as force is proportional to extension, so also extension is proportional to the length, to the force. I can also put extension equals to force multiplied by the force constant. And this my E again, which is the extension, will give me the change in length minus the natural length equals to F what? K indeed. Now the new length which we have here in the question is L25 minus the original length, which is L20, equals to the force given there is what? 50, then K. So if I take the difference between 25 and 20, that will give me what? 5 equals to 50 of K. I want to make that K subject the formula. I will have K equals to 5 over 50. And K will give me 0.1. Then I will go over it again. What will be its length when stretched by 100 Newton, assuming the elastic limit is not exceeded? I will go back again. My L minus LO is equals to FK. Then I want to get this new length, which is unknown. The natural length is given in the question, which is L20. But this time around, the force has now been increased to 100 multiplied by the constant, which I got as 0.1. So with this L minus 20, if I multiply 100 multiplied by 0.1, that will give me 10. So if I collect like terms, my L will give me 10 plus 20 indeed. So I will have the length now to be 30 in centimeter. So the way I have 30 centimeter there, which is option C. So our answer is C there. Now with the question, the velocity of sound in air at 16 degrees Celsius is 340 meters per second. What will it be when the pressure is doubled and the temperature is raised to 127 degrees Celsius? Velocity of sound actually is inversely proportional to the square of its temperature in Kelvin. So if I remove sign of proportionality, I will introduce a constant. So making constant subject to the formula, I will have K equals to V over square root of the temperature. So if I have V1 over square root T1, I will have V2 over square root of T2. But in the question here, my initial temperature was 16 degrees Celsius and the initial velocity was 340 meters per second. So if I want to convert that 16 to degrees Celsius, Kelvin, what I will have to do is to add 273 to it, and that will give me 289. So I want to get the velocity when the temperature is now increased to 127 degrees Celsius. So adding 273 to that degrees Celsius to make it Kelvin, I will have 400. So with what I have here, 340, the square root of 289 will give me 17. Then I'll have V2 still waiting. So the square root of 400 will give me 20. So what I will have to do here is now to cross multiply. So V2 multiplied by 17 equals to 340 multiplied by 20. So for me to get the V2, I will have to divide both sides by 17. So here I will have V2 equals to, but how many times can this 17 go in 340? It will go 20 times. So 20 now multiplied by 20, that will give me 400 in meter per second. And this one, if I want to make it standard form, I will have 4 multiplied by 10 raised to the power 2 in meter per second. So we look at the option D there. 4 multiplied by 10 raised to the power 2. So we go to the next question, question number 7. So question number 7, we are given the question, an object is embedded in a block of ice 10 centimeters below the plane surface. If the refractive index for the ice is 1.5, the apparent depth if the object below, that should be the apparent depth of the object below the surface is. Now, with what we have here, the apparent and likewise the real depth, how can we now relate it with that refractive index? Then we have the refractive index for the ice now, having real depths over the apparent depths. So refractive index in the question is given as 1.5. And we're being asked the apparent depth now if the object of the object below the surface. But the real depth in the question already is given as 10. So over, let us now have the apparent depth now as unknown to be x. So what we have to do now is to cross multiply. So the same 1.5 can still be 3 over 2 indeed, equals to 10 over x. So if I cross multiply, I'll be having 3x here equals to 2 multiplied by 10, which will give me 20. So dividing both sides now by 3. So how many times will this 3 now go in 20? It will go 6 times. Remainder 2. So that 2 again, if I add 0 to it, I will have it 3 in 20 again. That will be 6, and it will continue 6, 6, 6, 6. So I can now make it to 2 decimal place as 6 point, maybe to 1 decimal place, 6.7 in centimeter. So the answer to that question will give us 6.7, which is option A. So can we now go to the next question, where we have the lower and the upper pitch point of a thermometer are 30 millimeter and 180 millimeter respectively. Calculate the temperature in degrees Celsius when the thermometer reads. So we can have the lower fixed points as L, 0. And the lower fixed point there, we have it as 30 millimeter. Then the upper fixed points are the highest temperature of 100. So we have that one as 180 millimeter. And for us now, if you now mix that lower fixed point and the upper fixed point, then we are arriving at a particular temperature of LT. So now, what's now formula that connects the lower fixed point, then the upper fixed point, and the resultant temperature? So we have theta over 100 equals to LT minus LO over L100 minus LO indeed. So this temperature is what I'm looking for. Theta, which I don't know, over 100 equals to. Then the limit temperature now give us 45 indeed in millimeter as well. So if I have 45 here minus 30, I also have 180 minus what? 30. So with that, if I have theta over 100, so if I take away 30 from 45, that will give me 15. So also taking away 30 from 180, I will have 150. Then 15 can go in 150 10 times. So if I cross multiply, I will have 10 theta here equals to 100 on the right hand side. So how will I now get the value of this theta? I will have to divide both sides by 10. So my value of theta will give me 10 in degrees Celsius. So, which is option A there. So shall we now go to the next question? So for the next question, as it reads, 4,000 joules of heat is applied to 1.5 kilogram silver pendant, initially at temperature of 15 degrees Celsius. So determine its final temperature. Then we are given latent heat as 336 joule per kilogram. Then specific heat was also given 233 joule per kilogram per Kelvin. So what I will have to do here, the heat, the energy now, the energy given. So the mass will still remain, L. Then the latent heat, L. So I will also have the mass now also given for the specific capacity, C for specific capacity, then the temperature rise. So this temperature again, I will have the initial and likewise the final. In that case, I can still put my formula Q equals to ml plus mc then into theta 2 minus theta 1. Where that theta 2 will give me my final temperature, then theta 1 will give me my initial temperature. And the quantity of heat now is 4,000 in the question. The mass has not changed, 1.5 multiplied by what we have as the latent is 336. Then plus the mass has not changed, is still 1.5 multiplied by the specific heat capacity, which is 233, into the final temperature is what we don't know. But the initial is given as minus what? 15. So if I actually open this out, multiply this, then I open this with a bracket, I'll multiply all through. So making this our theta 2 subject to the formula, you eventually arrive at 26.4. 26.4. So can we go to the next question? So for the next question, an object 3 centimeter placed on the axis of a converging lens forms an image 30 centimeter from the lens. If the focal length of the lens is 15 centimeter, the height of the image is, we don't know. But then, we can think of that object has a height, which is 3 centimeter. So I can put it as object height, 3 centimeter, on the axis of a converging lens forms an image. That image here, I can have it as image distance, which I'll put as V, equals to 30 centimeter from the lens. We're given that if the focal length of the lens is 15 centimeter, so F for the focal length is 15 centimeter. Then I can also have the object distance as well, which I can denote as U. I have it unknown. So let me first of all get the value of my object distance using the parameters of the image distance, then the focal length using the lens formula. 1 over F equals to 1 over U plus 1 over V. So with the focal length 1 over 15 here, I don't know the object distance, but I know the image distance, which is 30 indeed. So I want to make use of the formula. I will have to transfer this 1 over 30 to the left hand side, where I will have 1 over 15 minus 1 over 30 equals to 1 over U. So the LCM of 15 and 30 will give me 30. So 15 in 30 will give me 2, minus 30 in 30 will give me 1. Multiplied by 1 will still be 1, equals to 1 over U. So 2 minus 1 will give me 1 over 30 equals to 1 over U. So if I cross multiply, U multiplied by 1 will still give me U. 30 multiplied by 1 will still give me 30 in centimeter. But the question says I should get the height of the image. Then a formula will now connect where we have magnification, giving image height over the object height equals to the image distance over the object distance as well. But I'm looking for the height of the image, which I will have as IH here unknown, but the object height is 3 centimeter. Then the image distance where we have it given here, U, 30 centimeter. And from the question, we're given the object image distance, which is also what? 30 centimeter. So if I cross multiply, this is now going to give me 90, and this one will give me 30 of my image distance equals to 90. So dividing 90 now by 30, it will give me 3 centimeter. So the image height will be 3 centimeter, which is option A there. So shall we now go to the next question? So for the next question, we have a hydraulic press as a large circular piston of radius 0.8 meter and a circular small plunger of radius 0.2. So a force of 500 Newton is exerted by the plunger. Find the force exerted on the piston. So hydraulic press actually work on the principle of pressure, which has to follow Pascal's principle. And formula for pressure will give us force over area. So since we're having piston on one hand, then we also have the anger on the plunger on the other hand. We can have F1 over A1 equals to F2 over A2. Then that force F1 will be for the piston. Then the force F2 now will now be for the plunger. So the question now asks, find the force exerted on the piston. That means the piston has no force being exerted yet, but it has an area of 0. That is the radius now. So when I square the radius, that will give me the area there. So for the plunger, I have 500 Newton. Then for the radius, where we have it as 0.2 also being squared now. So what I will have to do, if I have F over 0.8 multiplied by 0.8 will give 0.6L4 equals to 500. So 0.2 multiplied by 0.2 will give 0.04. So what I will have to do now is to cross multiply. So F multiplied by is 0.04 will amount to 500 multiplied by is 0.64. So for me now to get F, I will have to make F subject to the formula. So F now give is 0.64 multiplied by 500 over is 0.04. So after dividing, multiplying and dividing, we'll still arrive at that 8,000 as our answer, which is option A. So if you multiply and divide, arrive at 8,000 in Newton. So that will go to the next question again. So for this next question, we have a 3 meter cube volume of liquid W, and the W with a volume of 3 meter cube has a density 200 kilogram per meter cube is mixed with another liquid L of volume 7 meter cube and density 150. The density of the mixture now is what we actually want to get. Then we go back again. Density will give us mass over volume. So we want to get the total density in both. So what I will have to get for the total density, since I was given 200 kilogram per meter cube and 150 kilogram per meter cube, so I will have the total density first as, better still I was given the density and likewise the volume. I will have to get the mass. So I will make mass of the subject of the formula, density multiplied by volume. So for W on its own, so I will have to get, since the density is given, which is 200, then the volume is what? 3. When I multiply, I will have 600 now in kg. That is for W. Then for L as well, I will also use the same formula where I have mass again equal to density multiplied by volume. So I will have the mass as 150 for the density, then 7 for the volume. And amounting that, I will have 1050 in kilogram. But the question says I should get the density of the mixture. So I will come back. So I will have to add up the two dense masses. So that will give me 1650 50 indeed. So in kilogram. Then the volume as well, V1 plus V2. So I'll have 3 plus 7. That will give me 10 meter cube. So I'll go back to the formula of density again, where I have density equals to mass over volume. So the total mass now, 1650, then divided by 10. So 0 cancel out to 0. I'll be left with what? 165. Now in kilogram per meter what? Cube, which is option B. So shall we move to the next question? We're given here that a quantity of water at 0 degrees Celsius, that is the initial temperature, is heated to about 30 degrees Celsius. Then one of the effects of heat is an expansion. But the question now says at each degree rise in temperature, the density will do what? So when we have increase in volume, then there should be bound to be decrease in density. So the density will first of all actually decrease, then over time it will now rise. And it will rise at a particular temperature, which we have as 4 degrees Celsius. And that is where we can have the maximum density of our water. And that's actually explain our anomalous behavior of water. So the answer to that question will be, it will fall initially, then over time, then what? Rise. So we'll go to the next question from here. Then we are given some of these factors here. Then the first factor, we have it as reproducibility. Then we have another one, sensitivity. We have high thermal capacity. Then we have high accuracy. Then the question now says, the quality of a good thermometer includes. So a good thermometer has to have a high sensitivity. It must also have high thermal capacity. Then it must be of high accuracy. In that case, we have 2, 3, and 4 that are properties of a good thermometer. And which option actually goes with that? Which is option C. So we can go to the next question. So for the question number 15, the equation of a wave traveling along the positive x direction is given by the function 0.5 multiplied by 10 raised to the power minus 3 sine into 500t minus 0.025x. The same function can be represented as this: a sine into wt plus or minus then ks indeed. And this can be further expanded into a sine 2 pi f into t plus or minus 2 pi x over lambda, where the f here stands for the frequency, then the lambda here stands for the wavelength. So then in the function given in the variable given in the question, we have it as 0.25 times 10 raised to the power minus what? 3 sine into 500 then t minus is 0.0025x. So the equivalence of the amplitude here is the same thing as 0.25 multiplied by 10 raised to the power minus 3. In that case, the answer goes as 0.25 multiplied by 10 raised to the power 3 minus 3 in meter, because the unit for amplitude is measured in what? In meter. And amplitude actually will give us the maximum displacement of a body from rest. So the answer to that question is A. So the colors seen in a soap bubbles are due to. So we have option of interference, which is a property of wave. Dispersion actually explains the scattering of white lights as it passes through a glass freezing. And the colors now in that scattering of the white light, we have it in this form with a formula of real GIF, where reds, R stands for reds, then O for orange, yellow as Y, then G for green, B for blue, I for indigo, then V for violet light. So in that scattering of white light, red is now deviated the least, then the violet the most. So these 7 colors actually also constitute the colors we have in rainbow. And so for the bubbles, the color stains in a soap bubble are due to dispersion of white light. Then the case of diffraction is also another phenomenon for the waves, and likewise refraction. So the answer to that question comes as dispersion. For this question, a certain manufacturer wishes to make an N-type semiconductor. Which material will it select for doping? So for a semiconductor, it actually comes in between a conductor and a non-conductor. And we have 2 types of this semiconductor, where we have the P-type semiconductor and the N-type semiconductor. So for us to have an N-type or the N-type semiconductor, we need arsenic and likewise antimony, which comes as option B. So next question. So when impurities are added to semiconductor, the conductivity of the semiconductor, will it remain constant? Will it increase then decreases? Will it actually increase or decreases? So at high temperature, a semiconductor will start to conduct. So changing from semiconductor to a conductor. So in the case of adding impurity to it now, we are actually doing a kind of increasing the conductivity of such a material. In that case, when impurities are added to semiconductor, the conductivity of the semiconductor increases. So option C is the answer. Now we have this one, a radioactive substance has half-life of 20 days. What fraction of the original radioactive nuclei will remain after 80 days? So we have a formula that actually will help us to solve this. So we have NT over NO equals to half raised power T over T half. So the NT actually tells us the atoms after disintegration, the number of atoms after disintegration. Then the NO stands for the atom before disintegration, which is the original atom. Then the T, capital letter T here, is the time of disintegration. Then for this T half will now give us the half-life. Then the question now says, what fraction of the original radioactive element will remain after 80 days? So we have NT now, where we have it as so we have NT over NO equals to half will still remain what we have here. Then after 80 days for 80, then the half-life was actually given for 20. So NT now over NO equals to half raised power. So how many times will 20 now go in 80? It will go 4 times. In that case, our NT over NO is telling us we have half in 4 places. 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2 and multiplied by 1 over 2. So the value of NT over NO now will give us 1 multiplied by 1 multiplied by 1 multiplied by 1 should give us 1. Then 2 multiplied by 2 already is 4. And that 2 multiplied by 2 will give us 4. So 4 multiplied by 4 will give us 16. So the answer to that question will give us 1 over 16, which is option C. So next question. So for the next question now, we are asked if the frequency of an emitted X-ray is, so that's frequency F, we have it as 1.6 multiplied by 10 raised power 16 hertz indeed. Then accelerating potential we don't know, but we're given that 1 electron gives us a value of 1.6 multiplied by 10 raised power minus 19, and Planck constant we have it as 6.63 multiplied by 10 raised power minus 34. Then this same frequency we can relate it with energy equals to HF. Then this same energy again can be in electron volts. So if you are now equating HF equals to electron volt, now what we actually want to get is the potential difference, which is V. So make V solve the formula where we have H F over E. So if you're now going to actually have the value substituted, so 6.63 multiplied by 10 raised to the power minus 34 multiplied by the frequency 1.6 times 10 raised to the power 16 indeed, over the number of electrons 1.6 multiplied by 10 raised to the power minus 19. So this 1.6 will cancel out this 1.6. So we are left with minus 19 coming up to become plus 19. So 6.63 multiplied by 10 raised to the power minus 34. Now multiplied by 10 raised to the power 16 plus 19. So eventually we have 66.3 in volts. So the answer will give us 66.3 in volts, which is option B in there.